Okay, so welcome to our talk on securing Kubernetes clusters with Notary and TUF. We're going to talk a bit about ensuring the security of container workloads using trusted images. That's kind of the Notary part of things. Then we're going to talk about how you would go about applying this to your Kubernetes clusters. We're going to introduce our open source solution to solve this problem. And then we're going to go through a bit of a demo of it in action. So my name's Liam White. I'm a software engineer at IBM Cloud. I work on the IBM Cloud Container Registry team. So that's Docker Registry as a Service offering for IBM Cloud. And I'm also a core contributor on Istio. Twitter handle's up there. If you've got any feedback on the talk, let me know. Hand over to Michael to let him introduce himself.
Cool. My name's Michael. I'm on the same team as Liam, and I've contributed to the Notary project. There's my Twitter and GitHub credentials. Feel free to send me messages if you have any questions or anything. Okay, so I want to kick off with a simple statement. Security is hard. It's a really challenging problem to solve effectively. With security, you get a balancing act between control and freedom. The more towards control you go, the slower you can move. And there's potentially big problems if you get that wrong. There's no one-size-fits-all solution for it either. Finding the right balance is up to you and your company. Containers have improved freedom and velocity, but does that come at the cost of control? If you're running containers in your production environments, how can you make sure that the apps that run inside your production environments are what you think they are, and that you trust the content inside them? I'm not talking about who's deploying here, I'm talking about what. The problem of who deploys things is solved by RBAC configuration inside your cluster and controlling who has access to perform operations. But if you've got multiple people deploying to production, that doesn't control what they deploy. You have multiple clusters, maybe, for your development and your staging and your production. What's to stop somebody who's allowed to deploy stuff to production accidentally deploying dev code there? Or a third-party app that hasn't been properly audited? And speaking of which, if you've got requirements that code needs to be vetted by certain teams, like security or QA, before it goes to production, how can they sign off on a release before that goes to production? And is there a digital footprint of that your cluster can verify and assert that that's been carried out before allowing that to be deployed? And that the content that's being deployed is the content that was reviewed in the first place? That didn't work. That's died. Okay. What about the bad guys as well? If you have malicious third parties that get access to your container registry, how can you protect against them being able to replace your production app code with something nasty? The answer to that is to digitally sign it. Trusted digital content's a solved problem. You use a digital signature. But where do you store those signatures for container images? Enter Notary. Notary is a CNCF project that allows you to sign stuff. It first started out as being part of the Docker content trust stack. And it allows you to store trusted data and allows you to verify who has approved it. It implements a specification called the update framework, which is designed for secure yet flexible verification of production assets. It's got handy stuff for outage-free verification of things, so you can rotate your keys easily and things like that. It's good to check that out. The website was in the keynotes. I think it was theupdateframework.io. Now, the content that we store in this case is Docker image digests. A Docker image digest is the SHA-256 hash of the image content. Now, at the moment, there's no known vulnerabilities in SHA-256 that allow you to replace the content inside something with something that gives the same hash. All the vulnerabilities that I'm aware of, at least, allow you to replace a hash thing with some other data. But basically, if you've got a hash and you know that that content is the same. When you have a tag for a Docker image, that's a human-readable link to a SHA-256 digest. But that's not immutable. You can change what that link points to. If you replace latest on your registry, that's what you're doing. You're just pushing a new link to a different digest. So that's really not working. Normally when you pull an image, Docker queries the registry for the digest associated with the content of that image. In this case, I'm using simplified language, but the daemon asks the registry for the digest for Ubuntu latest. The registry gives you that. And then it sends a subsequent request to the registry to pull the content for that repository at that digest. At that point, the daemon knows that it's expecting the content to have a certain hash, and so it can verify that when it pulls the image that that is complete. Where Notary fits in is that instead of going to the registry, it can go, the Docker daemon can go to Notary instead. That way, when Notary responds, it can give you the signed content and also all the signatures of it. And so where your Docker daemon trusts a certain person, they can verify that their signature checks out before then sending the request to the registry to pull the content. Now, why not just use Docker Content Trust as it comes in your cluster? You can go onto your cluster workers and restart the Docker daemon just with the flag to force Docker Content Trust to be turned on. The big problem with doing that is that Docker Content Trust is an on or an off option. If it's on, everything has to be signed. If it's off, it doesn't verify anything. But what if there's other people that you trust? Some things like the kubelet images aren't necessarily signed, but you still want to be able to run them in your cluster. If you want to run Prometheus or things like that, they might not be signed, or at least the latest versions might not. You might need to decide whether you want to copy those into your own namespaces and sign them yourselves and audit them that way. But yeah, it's an out-of-the-box install of Kubernetes won't behave very well if you just turn Docker Content Trust on. Put simply, Docker Content Trust isn't powerful enough for Kubernetes. Kubernetes is a powerful tool that deserves powerful trust management and more control over what you can deploy and where, rather than just enabling DCT on your nodes. So we need an application that enables the cluster to communicate with the trust server before deploying your workload. Now, conveniently, Kubernetes has an API to do that, and it's called an admission controller. And I'm going to hand over to Liam, who's going to dive into how those work and how we can apply it.
Are we down a clicker?
I mean, you can try it.
OK. It works again, though. It's my clicker. Maybe it only works for me. So admission controllers. Admission controllers are basically webhooks that are triggered during resource creation. So if you go into the background of what happens when you create a resource in Kube or a workload, so a pod, something like that, you create the resource with kubectl apply. The API server receives that request. It adds and mutates information into that request. So things like if you're using service accounts to register your image pull secrets, it will mutate that information into there at that point. It then stores or persists that information in etcd, and then the kubelet checks against the API server and then actions what the API server tells it that node should look like. So recently, Kube have added the ability to add custom admission controllers. So these custom admission controllers work in the same way that the built-in ones work. They're triggered during the creation of the object by the API server. So after authentication and authorization against the API server, the Kube API server then reach out to some of these admission webhooks, and they'll respond with the relevant information. The customization of ACs or additional ACs allows you to add the custom mutation. So that's how you would go ahead and kind of fix the digest. So there are two types of webhooks. Is this me buzzing? There are two types of webhooks that are of interest to us. So, didn't work. We've got validating admission webhooks, which were added in Kube 1.8, and validating admission webhooks are basically a yes or no, you can't deploy this thing. And then we've got mutating admission webhooks. Mutating admission webhooks are basically a yes, you can deploy this if you apply these patches, or no, you're not allowed to deploy this at all. So how does this relate to Notary? Well, like Malcolm mentioned earlier, generally when you create a workload in Kubernetes, you're going to give it the full image name with the tag. And like Michael said, that's not immutable. That's just a pointer to a digest somewhere. And how do we know someone hasn't pushed over top of this? What we want is something immutable. So what we want is something that looks like that, which is the digest. And preferably, we want to be able to ask Notary, we want some kind of secure guarantee that the digest itself is correct and it hasn't been tampered with, and that's where Notary comes into this equation. So if you install a mutating webhook, this is kind of the flow you would do with Notary. So resource creation request comes in, the API server will call out to your mutating emission webhook. The mutating emission webhook will ask Notary for the trust information for all of that image repository. So for every tag, basically, it'll give you a collection of digests back, and it will send the signatures back, like Michael mentioned. The mutating webhook will then look for the most recent trusted digest and mutate and send back a mutation request to the API server. So what do these look like? This is kind of, this is generic admission or mutating admission webhook requests, or general requests, I think. It's all admission requests, right? Yeah. So if you wanted to use your own, you can use some of this information as well, but I'm going to give it a specific example of what we're doing. So this is the API server calling out to the webhook. It has a UID, it has a kind and a resource, which is pod and pods in this case. It has the namespace the workload is being deployed into, and it has the operation, so this is a create, and then it has the object, which is the JSON byte slice of the actual object you're trying to create. So what basically this request is saying is someone is trying to create a pod in the default namespace. Now response, this is an admission response struct. It looks something like this. So we've got the UID again. That will have to match the UID of the admission request. We've got allowed. This is the true or false, yes, you're allowed to deploy this. If you're not allowed to deploy this, it's usually useful to give the API server a message to give back to the user. So this particular one isn't a very useful image message because it just says untrusted image. We give better error messages than that, but this is just an example, and we're going to return the 401 code there. Now, it'll also have to contain a patch type, so this is JSON patch, which is an IETF standard, and the patch itself, which is a byte slice of a slice of patches. So what does a patch look like? Again, this is just the IETF JSON patch standard. We've got the operation, which is replace. We're saying to the API server, I want you to replace the first container in the pod spec and the image field in that first container. That's what that container /0/image is. And then the value I want you to replace it with. So what we've now effectively done is we've taken the tag that you asked to be created and we've verified with Notary that this is the digest you actually wanted, and that's what we're going to deploy. So we've come up with an open source solution for this problem. It's called Portieris. Portieris means gatekeeper in Greek because all good Kubernetes projects have to be in Greek. It's open source and available here on github.com/IBM/Portieris. Currently, we only support the IBM Cloud Notary server, but we're happy to work with people to support your Notary instances. The reason that this isn't necessarily a trivial task is because you have to map the Notary server to the registry that it talks to, and that's obviously going to be via the image name. And with our own one, we obviously know how that maps and that type of thing, but with more generic solutions, we need to come up with for more generic Notary server instances, we need to come up with a more generic solution. So like I said, we're happy to work with other people to support others' Notary instances. So as a security tool, it was designed with security in mind. So if you haven't got any policies so if you haven't defined any policies, we're just going to blanket block everything. The idea is you have to whitelist images. So that's general security best practice of whitelisting rather than blacklisting. We fail close, so this prevents someone from basically breaking through and deploying something if Portieris is down. So Portieris might be down for a configuration issue, or some malicious actor has intentionally taken it down by DOSing it in order to deploy their stuff, or maybe a bug. Hopefully not, but maybe. We also have namespace and cluster-wide granularity. So if you're managing a multi-tenant cluster for a group of developers, you can define specific policies for specific namespaces, kind of like you do with cluster roles and roles. It's a similar thing. And we've written it in a way so that it's easier to build other image checks on top of it. So what this means is if you want to do other image validation, you can reuse a lot of our libraries and our code and that type of thing. So internally, the IBM Cloud Registry has a vulnerability advisor. Internally, we have code that reuses a lot of the open source code, and then it builds on top of the CRD. You have to do some CRD regeneration of the client set code, so people who have written controllers before know that there's a CRD generation for the client set, so you'd have to do that, and then obviously you have to write your own custom code to handle that policy when it comes in. But it's relatively easy. So this is our cluster image policy definition. So basic kube CRD, we've got a policy spec and the repositories field, or the repositories here, which is a slice of basically Docker or registry repositories, sorry. So what this one is basically saying is I want, cluster-wide, I only want images from the limwhite/kubecon Docker Hub namespace as long as they've been signed by someone. There's no trust pinning here. This is just a blanket someone has signed them. That's not a very realistic example, so let's go on to a more realistic example. So this, again, cluster-wide image policy. And what this one basically says is I want to be able to deploy anything from the limwhite namespace on Docker Hub as long as it has been signed by this public key and this secret. So that's what that signer secrets field is there, and the secret name. So this is what the secret will look like. This is obviously just create a normal kube secret. The metadata name has to match the signer secret name that was listed in the cluster image policy, so that secret name there, so we can find it. And then the data itself, so the name has to be the signer role that you're looking for. So that might be the QA team, the security team. That type of thing, that's what you need to check for. And then the public key is their public key that matches, obviously, the private key pair, or it matches the private key of the person who's actually signed the image. Now, if you want some Kubernetes namespace granularity as opposed to the registry namespace, which is a slightly different concept. So if you want to be able to enforce on just a specific namespace, then you would define something like this. This is exactly the same cluster-wide policy, but now we're just enforcing it on a single namespace. So partly due to time constraints, but mostly because we're cowards, we've got a pre-recorded demo. So I'll hand over to Michael, and Michael can guide you through it. You don't need that.
Nope. All right.
Click at the top.
How's this set up? Okay, so we've got demo. I'm going, oh, wrong way. There we go. It's a good start. Okay. So Portieris is a Helm chart. So the first thing I'm going to do is install Helm and initialize it to install Tiller. Then I'm going to clone the GitHub Portieris project and just change directory to where the Helm chart is. Next thing I'm going to do is install the chart. That's just a Helm install. We can dive a little bit more into what this is doing. In the top left, that's kubectl get all, just to show everything happening. Bottom left is our jobs, just to show our CRDs and things like that being created. Top right is the CRDs themselves, and the bottom right is that image admission config. That's our mutating admission webhook right there. So the jobs are all done, so that's pretty much done and ready to switch back. Cool. And you get a nice message to say we're done installing. So I'm going to look more into that mutating webhook. We create a configuration called image admission config. We're looking at, that's all the way down here, create and update on a whole bunch of resources. There's that failure policy to say fail. That will tell the Kube API server that if it's not there to respond to the request, to deny it. Okay, let's start deploying some stuff. Firstly, let's have a look at that cluster image policy. So we install a cluster image policy by default, and the requirements on that are to enforce trust for every image. So you've got name, star, trust enabled, true. So if I go and have a look at a workload, just move into my playground and look at Liberty. So Liberty is a IBM application server. It's just a handy image to pull from. At the moment, that's pulling from my private unsigned image of IBM Liberty. So if I quit that and then issue a kube apply, I've aliased kubectl to K because I'm lazy. But you see no valid trust data for unsigned. Unsigned is that tag at the end, but it's just handy that it fits there. So now if I go and edit the cluster image policy and go and disable that, so trust disabled, I'll set that to false. Now when I try to issue that same deployment again, so I'm just going to k apply liberty.yaml again without changing the file at all, that's allowed. You need to keep an eye out and make sure that you put proper RBAC on your policies because of that. In this case, I'm going to go have a look at that pod and just show down at the bottom in the logs, you can see that that has not actually changed the image at all because it hasn't actually gone and looked up the trust data because it's disabled. Cool. So let's enable trust again. So we're just going to go back into the cluster image policy and set that false back to true. And man, I type slowly. So now I'm going to deploy a signed workload. Now IBM's public images are all signed, so that's a really handy image to use. So I'm going to use the IBM Liberty public image from the Bluemix registry. So I've just changed that to, the different image that is now signed. I'll apply that, and that's deployed. So with trust enabled, a signed image gets deployed. And when I then should go and show the container, that one has been mutated. So container image, that digest, well, in this case, it was already present on the machine, but there you go. It's using that specific image at that specific digest. We want to do something more cool. We want to push our own signed workloads. So first, we're going to need to push a signed workload. So to that, we'll enable Docker Content Trust on our local machine. And now I'm going to do bxcr login, which is log in to the Bluemix Container Registry, because when you've got trust enabled, it gives you a handy printout to target the right trust server. And now we're going to push the image. So that's just a Docker push. It's exactly the same way as before. But this time, after pushing the image, it's also going to push some trust data into the Notary server. So that will prompt me to generate some keys. Excellent. And now that's a signed image, and that's signed in my private namespace in the container registry, and I can edit that deployment, put that signed image into the deployment, and deploy that with the trust verification enabled. So that's now set to my signed Liberty, and now I'll apply that just to show that that happens, and that's allowed, and so that gives me that that deployment was configured. Let's go one step further, though, and do proper trust pinning. So firstly, we need a signer key pair. So for that, let's generate one. We use docker trust key generate. The docker trust commands are new in Docker 17.12, I think, and they've just come out of experimental, but they're handy to interact with Notary. So I've created a public key pair. There's the public key. The private key automatically gets injected into my Docker trust chain, and I don't need to worry about it. I'm going to add that signer onto my repository. That will tell Docker to go and push that into the Notary. I need to give it the name, molepigeon, so I did trust signer add molepigeon. That's the name of the role, and then the key is molepigeon.pub. That's what I generated. Just so happens that I like molepigeon. It's just a thing. That asks me for the repository key, just to prove that I have the ability to add signers into that repository. It's sort of an authentication by keys. And now I'll just issue a sign command. Because I've got that private key on my machine, I can issue a sign, and this time it's asked me for the mole pigeon key. So now that image that we pushed before is signed using my mole pigeon key. Just to prove that, I'm just going to do docker trust inspect. You have to give that the pretty command now to make it not JSON, but there you go. And there you go. So that shows that the latest tag up there has that digest and has been signed by mole pigeon, who is me. And there's my key, just to prove that that is the right key. For reference, I'm also going to inspect the IBM public image, which is signed in a slightly different way. We're not using a specific signer role for that. We're just using the repository admin key. And so it'll tell you that on the signers, that's the repository admin. OK, so let's get that key into the cluster. We're going to do kubectl create secret to avoid writing some YAML. I'll call it my key, and I'll give it the name is mole pigeon. That was the signer role that I created. And I'll give it my public key. So that creates the secret, puts it into the cluster. Excellent. And now I can put that into an image policy to ensure it. I'm going to do a namespace policy, so an image policy, not a cluster image policy here, just because I can. And I just add the signer secrets section to this, and I give that the name with my key. That was the name of the secret that I created. OK. So now if I were to go and look at the workload that I was pushing before, that's working off of the signed public image, that's not signed by me. So when I quit this and I apply that into the cluster, that's rejected with a slightly less pleasant message, but there you go. But you can see at the bottom, no signature found for role mole pigeon. In other words, I haven't signed that image. And so if I then change that in my deployment to deploy off of the image that I just pushed, this one works. And that's what I've got. And that will show that that pod has been mutated. You can use that configuration to basically set that as fine-grained or not fine-grained as much as you want anywhere in your cluster. If you have multiple namespaces, that's weird. If you have multiple namespaces, you can add different policies for different teams to scale up to whatever size enterprise you've got.
OK, so that's the end of our talk. Our Twitter handles are on there if you have any feedback or further questions on Portieris. We can probably also answer some questions on Notary as well. We would like to ask you to go to GitHub repo and have a play around with it. If you come across any issues or you have any feature requests, just raise an issue on GitHub. And with that, we'll take questions.
There is, but we'll repeat it.
Notary creator, great work, guys.
Hi. Sure.
Point of clarity, when you talked about the password being authentication in the signer ad, all of the private keys are actually encrypted on the disk using PKCS 8. So the password is to decrypt the key. It's not just authentication.
Right. OK. It's David, isn't it? Yeah. David down here was just pointing out, when I said that that was to, when you added the signer and it asked me for the repository key, that was also decrypting the repository key on disk so that it can be used. Yes. under the covers, oh, there we go. Yeah, under the covers, the Docker Trust signers is basically creating a delegation role in Notary. They are the same thing. The question was, how would we integrate it with a CI/CD pipeline? So basically, you just install it into your cluster, and as long as your CI/CD is sending requests to the Kube API server or doing kubectl apply or things like that, then the emission webhook will run. Yeah, it's the same installation policy as before. Everything goes through the emission webhook.
You do need to make sure you sign the images when you're pushing them to the registry, though. That's the other thing.
What if your CI is pushing the images?
Yeah.
Then, yeah. Then in that case, you have to have Docker Content Trust turned on in order to push the images. And you have to give your CI the signing keys as well. So the public images in the Bluemix registry are pushed using CI/CD. The CI just has our key that we pull in from store in our backend. Yes?
How do you create a signature without having access to the Docker socket? So if your CI/CD, if your tool chain is containerized, is there any way you can push an image with a signature from inside the container? Probably not. Is there any way to handcraft?
You can use the Notary CLI. I'll let you speak about
Yeah,
that.
you can use the Notary CLI to sign the image, but if you have enough access to some Docker content in order to push, in order to instruct something to push the image, then you probably have enough to get it to sign the image. Actually, no, all the signing stuff is client-side.
Yeah, but if you push an image and then you're going through the verification step, and then after you made all the tests, you want to issue a signature that you now confirm that this is a valid image, you can use it, right?
Yep.
So you can produce a signature after you pushed an image to the registry already.
Yep.
So how in this case you can create a signature when the image is already in the registry?
So that's what I did with the Docker Trust sign command. That image was already in the registry and that wasn't adjusted. As long as the local machine is aware of that being the signed image and it has the latest trust data. So in other words, if you turn Docker Content Trust on before you pull the image in order to run your tests, then you can, then you can run Docker Trust sign afterwards.
You cannot run it inside a container.
You can't run the Docker Trust sign command inside a container. Is that what you do?
It's a privileged container, of course. But you don't
Yes.
You can run Docker Trust because it's clients. It's
Yeah.
client. It doesn't interact with the Docker daemon.
You can also just use the Notary CLI tool.
Yeah,
Yeah.
that too.
Docker.
Yeah.
Okay, thanks.
Yeah.
No, it's true. You can use the Notary CLI as well.
It's a community, right?
Yep.
It's easier with the Docker CLI.
Yeah. That's why we spoke about it. That's what we found as well.
Is it possible to require more than one signature? Or
Yes.
Yep.
It's a slice. Oh, it's an array, so you can just require as many as you want.
and that would, would it be possible to run multiple signatures, or is that one of the above signatures?
It's all of the one. So if you specify the signer secrets in your policy, it requires that all of those are present. There can be more, but it requires that all of the ones in the signer secrets are present.
Okay. If there are any more questions, we'll be outside to answer them. So thanks very much.